आपण अल्डिहाइड्स अँड कीटोन या नवीन टॉपिकचं डिस्कशन लास्ट लेक्चर मध्ये सुरुवात केलेलं होतं. दिस इज वन ऑफ द इम्पॉर्टंट टॉपिक फ्रॉम द ऑर्गॅनिक केमिस्ट्री. Aldehydes and ketone, they having wide applications in our synthetic organic chemistry because they are highly reactive compounds. Already we have studied what is meant by aldehyde and ketone, आणि त्याचा आपण नॉमेनक्लिएचर स्टडी केलेला आहे. अल्डिहाइड अँड कीटोनचं नॉमेनक्लिएचर. नाउ लेट अस सी नेक्स्ट पॉइंट. त्यामध्ये आपण पुढे जाऊया. लेट अस सी स्ट्रक्चर ऑफ कार्बोनिल ग्रुप. Aldehyde and ketone both are carbonyl compound. They having C double bond O group. Actually how they shows chemical reactivity हे स्टडी करण्याच्या अगोदर आपण कार्बोनिल ग्रुपचं स्ट्रक्चर थोडंसं बघूया. What is the structure of carbonyl group? Okay, this is the C double bond O group, carbonyl group. It may be present in aldehyde as well as ketone. First, about the hybridization of central carbon. What should be the hybridization of that central carbon atom? The hybridization of that carbon is sp2. In carbonyl group, in aldehyde or ketone, hybridization of that carbonyl carbon means one s orbital and two p orbital. They mix up and recast, and there is the formation of three new orbital, and that three new orbitals are called sp2 hybrid orbital, and that process is called sp2 hybridization. हे खूप डिटेल मध्ये आपण जात नाहीये, फक्त एवढं लक्षात ठेवूया. इन carbonyl group, central carbon is sp2 hybridized. Means there are three sp2 hybrid orbitals. Okay, now that three sp2 hybrid orbitals of carbon form three sigma covalent bond. That three orbital form three sigma covalent bond. Suppose this is the first bond, this one is the second bond, and this one is the third covalent bond. Means in carbonyl group there are three sigma covalent bond, and this bond is formed due to overlapping of sp2 hybrid orbital with another orbital. This is actually axial overlapping. This is axial overlapping. Suppose मी पुढे एकदा दाखवतो. Central carbon having three covalent bond. Okay, now in carbonyl group carbon there is a sp2 hybridization. Means there is a one more orbital which do not participate in the hybridization, and this is called unhybridized 2pz orbital. That carbon having unhybridized 2pz orbital. Suppose this is the unhybridized 2pz orbital of carbon. Similarly, oxygen also having unhybridized p orbital. This is the unhybridized orbital of oxygen, and this is unhybridized orbital of carbon. Now p orbital of carbon and p orbital of oxygen, they overlap laterally. They overlap sidewise with each other, and there is the formation of pi bond. This is the pi bond actually formed between two carbon, while that previous bond is the sigma. हा मात्र कुठला होता? This is the sigma bond, and thus in between that two carbon and oxygen there is a one sigma and one pi bond. कार्बोनिल ग्रुप मध्ये कार्बन आणि ऑक्सिजनच्या मध्ये डबल बॉन्ड आहे, and here one is a sigma and second is the pi bond. How that pi bond is formed? Pi bond is formed by the sidewise overlapping of p orbital of carbon and oxygen. Okay, this is just a pi bond formation. Okay, now what should be the geometry of carbonyl group? What should be the geometry of this particular group? There is a sp2 hybridization. Therefore, geometry should be trigonal. Here, this is the trigonal geometry in the carbonyl group. And bond angle should be 120 degree. Bond angle should be 120 degree because hybridization is sp2, and if hybridization is sp2, always that hybrid orbitals are reoriented trigonally in space. Hence, the bond angle should be 120 degree. Okay, this is just about the structure of carbonyl group. Actually, we are discussing about the aldehyde and ketone. Aldehyde and ketone, they are carbonyl compound, both having carbonyl group, and therefore we have studied structure of carbonyl group, because to study the chemical reactivity of that carbonyl group, to study the chemical reactivity of aldehyde and ketone, we must know about the structure of that carbonyl group, and hence we have studied the structure of carbonyl group. Okay, now let us see next point. Reactivity of carbonyl group. Okay, this is a carbonyl group. We know that in carbonyl group, oxygen is more electronegative than carbon. Among that oxygen and carbon, oxygen is more electronegative than carbon. Therefore, what happens? Here, this bonded electron pair, they are attracted towards oxygen, and oxygen having partial negative charge and carbon having partial positive charge. Means that CO bond, that carbonyl bond is polar. It is polar. It is ionic bond. Why it is ionic? Why it is polar? Because oxygen is more electronegative. Hence, it attracts this bonded electron pair. म्हणजे कार्बन आणि ऑक्सिजनच्या मध्ये जे बॉन्ड आहेत म्हणजे इलेक्ट्रॉन पेअर आहे. This electron pair is just attracted towards oxygen. Hence, it acquires partial negative charge, while carbon acquires partial positive charge. Okay, and thus that bond is highly polar. म्हणून हा bond highly polar आहे. Here, that carbonyl group may shows delocalization of pi electron. म्हणजे इथं जो pi bond आहे त्यामध्ये असणारी जी इलेक्ट्रॉन पेअर आहे, this electron pair maybe goes towards oxygen and it acquires negative charge while carbon acquires positive charge. Means that bond is highly ionic, that bond is highly polar. म्हणजे यावरून आपलं कन्क्लुजन काय असणार आहे? इन कार्बोनिल कंपाउंड, इन अल्डिहाइड अँड कीटोन, that CO bond, that carbonyl bond is highly polar, it is highly ionic. It having near about 40 to 50% ionic character. It having 42 means it having high ionic character. This is due to the difference in the electronegativity between oxygen and carbon. Its a dipole moment is near about 2.7 dBi, and this is highly polar molecule, and therefore it is more reactive. That molecule is highly polar and hence it is more reactive. Okay, now let us see example. I will explain the example. Okay, this is example of carbonyl compound, acetone molecule. As we know, it having carbonyl group. That carbonyl group is highly polar. Carbon having partial positive charge. Therefore, what happens? Nucleophile. Suppose there is a Cn minus. That nucleophile can be easily attacked on the carbonyl carbon. तो या कार्बोनिल कार्बनवर इझिली अटॅक करतो. का अटॅक करेल? बिकॉज दॅट कार्बोनिल कार्बन इज हॅव्हिंग पार्शियल पॉझिटिव्ह चार्ज. इट हॅव्हिंग इलेक्ट्रॉन डेफिशियन्सी. Nucleophiles are negatively charged. They easily attack on that carbonyl carbon. They easily attack on the electron deficient carbon, and hence that carbonyl compound, that acetone, undergoes nucleophilic addition reaction. Carbonyl compound easily undergoes nucleophilic addition. Why? Because that central carbon is electron deficient. It having partial positive charge. म्हणून त्यावरती न्यूक्लिओफाईलचा अटॅक इझिली होतो. मग न्यूक्लिओफाईल म्हणजे Cn मायनस आणि कार्बोनिल कार्बन यामध्ये नवीन बॉन्ड तयार होतो. मग इथं जर नवीन बॉन्ड तयार होत असेल तर इथला पाय बॉन्ड ब्रेक होतो. इलेक्ट्रॉन पेअर गोज ऑन द ऑक्सिजन. इट ॲक्वायर्स निगेटिव्ह चार्ज. त्यावरती निगेटिव्ह चार्ज येतो इथं आणि यामध्ये नवीन बॉन्डचं फॉर्मेशन झालेलं आहे. अँड वी गेट द इंटरमिडिएट आणि आपल्याला इंटरमिडिएट मिळतो. नाउ दिस इंटरमिडिएट फर्दर कंबाईन विथ H प्लस. पुढच्या स्टेपमध्ये H प्लस ची ऍडिशन ऑक्सिजनला होते अँड वी गेट द ऍडिशन प्रॉडक्ट. म्हणजे ऍक्च्युअली कार्बोनिल कंपाऊंडला हायड्रोजन सायनाइडचे ऍडिशन होते. हायड्रोजन सायनाइड ऍड्स टू द कार्बोनिल कंपाऊंड अँड ड्युरिंग दिस ऍडिशन देर इज अटॅक ऑफ न्यूक्लिओफाईल. Hence, it is called nucleophilic addition. Why nucleophile attacks on the carbonyl compound? Because carbonyl group is highly polar. Carbonyl carbon is electron deficient. It having positive charge. Therefore, nucleophile, which is negatively charged, it easily attack on the carbonyl carbon and it undergoes nucleophilic addition reaction. This is very important point. Okay, now let us see next point. Some factors which affect on the reactivity of carbonyl group. We will see some factors which are responsible for the reactivity of that carbonyl group. We are going to study two factors which are responsible for carbonyl group. One is a steric effect and second is the inductive effect. Let us see first one, steric effect. Actually, स्टेरिक इफेक्ट आपण कशाला म्हणतोय ते सुद्धा आपण बघूया. पण त्या अगोदर मी काही एक्झाम्पल्स तुमच्या समोर ठेवतो. ओके, फर्स्ट एक्झाम्पल इज द फॉर्मॅल्डिहाइड. HCHO, formaldehyde. Second is the acetaldehyde, example of carbonyl compound. Third one is the acetone, and fourth one is actually that carbonyl group is attached to the isopropyl group from one side, isopropyl group from another side. It is diisopropyl ketone. Okay, this is the diisopropyl ketone. Okay, मी steric effect आपण कशाला म्हणतोय? Suppose there is a crowding of alkyl group around the reaction center. If there is a crowding of group around the reaction center, then this is called steric effect. मग सपोज जर कार्बोनिल ग्रुपच्या भोवती क्राउडिंग असेल, गर्दी असेल, then the chance of nucleophile to attack on the carbonyl group decreases. तो थोडासा कमी होतो. फॉर एक्झाम्पल, हे शेवटचं एक्झाम्पल आपण घेऊया. दिस इज द कीटोन. या कार्बोनिल ग्रुपच्या भोवती काय आहे? अल्किल ग्रुपची गर्दी आहे. त्यामुळे काय होतं? क्राउडिंगमुळे न्यूक्लियोफाइल कॅनॉट इझिली रीच अप टू द कार्बोनिल ग्रुप. तो कार्बोनिल कार्बन पर्यंत इझिली पोहोचू शकत नाहीये या क्राउडिंगमुळे. दिस इज कॉल्ड स्टेरिक हिंड्रन्स. दॅट इज कॉल्ड स्टेरिक हिंड्रन्स. And due to steric hindrance, that compound, that carbonyl compound is less reactive towards nucleophilic attack. It is less reactive because there is a crowding around the reaction center. There is a crowding around the carbonyl group, and therefore it is less reactive. Hence, that last example is a less reactive. Now, what's about the acetone? Acetone मध्ये there are two methyl group around the C double bond O group. Means comparatively crowding is less. म्हणजे पहिल्यापेक्षा क्राउडिंग या ठिकाणी कमी आहे ऍसिटोन मध्ये. त्यानंतर पुढचं एक्झाम्पल बघूया, असिटाल्डिहाइड. इन असिटाल्डिहाइड देयर इज ओनली वन मिथिल ग्रुप. देयर इज अ लेस क्राउडिंग. व्हाइल इन द फॉर्मॅल्डिहाइड देयर इज ओनली टू हाइड्रोजन एटम. मीन्स देयर इज अ नो क्राउडिंग. Hence, in that case, formaldehyde is a more reactive. Formaldehyde is more reactive because there is a no steric effect. There is a no crowding around the carbonyl group. And hence it is more reactive than acetaldehyde, which is more reactive than acetone, and which is more reactive than diisopropyl ketone. This is just about the reactivity order, and this is based on the steric effect actually. Then second one is the inductive effect. Okay, I will explain here actually how the inductive effect plays role in the reactivity of carbonyl group. Let us see general example. Okay, this is simple carbonyl compound. It may be aldehyde or ketone. It's having C double bond O group. We know that in C double bond O group, here there is a double bond between carbon and oxygen. That oxygen is more electronegative. Hence, that bonded electron pairs are attracted towards oxygen. That oxygen acquire partial negative charge. Carbon acquire partial positive charge. Okay, and thus we know that carbonyl group is a polar. It is highly ionic. Okay, आणि मग तो न्यूक्लियोफिलिक एडिशन का दाखवतो? बिकॉज कार्बन हॅव्हिंग पॉझिटिव्ह चार्ज. देअरफॉर न्यूक्लियोफाइल कॅन बी इझिली अटॅक. म्हणून न्यूक्लियोफाइलचा त्याच्यावरती इझिली अटॅक होतो. अँड देअरफॉर इट इज हायली रिॲक्टिव्ह. तुम्हाला सर्वांना माहिती आहे व्हॉट इज मीन बाय इंडक्टिव्ह इफेक्ट, किंवा मी थोडंसं एक्सप्लेन करतो. हिअर दिस आर ग्रुप इट शोज इलेक्ट्रॉन डोनेटिंग इंडक्टिव्ह इफेक्ट. म्हणजे हा जो आर ग्रुप आहे, अल्किल ग्रुप आहे, तो इलेक्ट्रॉन डोनेटिंग इंडक्टिव्ह इफेक्ट दाखवतो. म्हणजे काय? तर या दोन्हीच्यामध्ये असणारी जी बॉन्डेड इलेक्ट्रॉन पेअर आहे, इट डोनेट दिस बॉन्डेड इलेक्ट्रॉन पेअर टुवर्ड्स कार्बन. कार्बनकडे ही इलेक्ट्रॉन पेअर तो पुश करतो. ऑल द अल्किल ग्रुप दे हॅव्हिंग प्लस आय इफेक्ट. ऑल द अल्किल ग्रुप दे शोज इलेक्ट्रॉन डोनेटिंग इंडक्टिव्ह इफेक्ट. म्हणून काय होतं? हे दोन्ही अल्किल ग्रुप ही बॉन्डेड इलेक्ट्रॉन पेअर या सेंट्रल कार्बनकडे पुश करतात. आता ही जी इलेक्ट्रॉन पेअर आहे सेंट्रल कार्बन कडे पुश केलं तर काय होतं? सेंट्रल कार्बन हॅव्हिंग पॉझिटिव्ह चार्ज. मग काय होतं? तो पार्शियल पॉझिटिव्ह चार्ज थोडासा कमी होतो. वाय इट डिक्रीजेस? तो का कमी होतो? बिकॉज दॅट अल्किल ग्रुप शोज इलेक्ट्रॉन डोनेटिंग इंडक्टिव्ह इफेक्ट. अल्किल ग्रुप इलेक्ट्रॉन डोनेटिंग इंडक्टिव्ह इफेक्ट दाखवतात आणि म्हणून त्यावरचा पार्शियल पॉझिटिव्ह चार्ज हा कमी होतो. आले लक्षात? आणि त्यामुळं पॉझिटिव्ह चार्ज जर कमी झाला तर न्यूक्लियोफाइलचा अटॅक जो व्हायला हवा तो इझिली होत नाहीये. द चान्स टू अटॅक द न्यूक्लियोफाइल ऑन द सेंट्रल कार्बन इट अगेन डिक्रीजेस. थोडंसं व्यवस्थित समजून घ्या मी काय सांगतोय ते. जनरली इन कार्बोनिल कंपाऊंड वाय न्यूक्लियोफाइल अटॅक ऑन द सेंट्रल कार्बन? बिकॉज सेंट्रल कार्बन हॅव्हिंग पॉझिटिव्ह चार्ज. Therefore, nucleophile, which is negatively charged, it attacks on the central carbon and it undergoes nucleophilic addition. Okay, this is the general trend. But suppose there is a plus I इफेक्ट. जर सेंट्रल कार्बनला दोन अल्किल ग्रुप जोडलेले असतील तर काय होतं, अल्किल ग्रुप प्लस आय इफेक्ट दाखवतात. मग प्लस आय मुळे काय होतं, सेंट्रल कार्बन कडे ही इलेक्ट्रॉन पेअर पुश केली जाते, ढकलली जाते. त्यामुळे सेंट्रल कार्बनवरचा पॉझिटिव्ह चार्ज कमी होतो, कारण दिस आर द इलेक्ट्रॉन. मग इलेक्ट्रॉन हे निगेटिव्हली चार्ज आहे म्हणून त्यावरचा पॉझिटिव्ह चार्ज कमी होतो. आणि जर पॉझिटिव्ह चार्ज त्यावरचा कमी होत असेल तर न्यूक्लिओफाईलचा अटॅक जो त्यावर व्हायला हवा तो इझिली होत नाहीये. अँड hence the attack of nucleophile, the chance to attack of nucleophile decreases and therefore its reactivity also decreases. म्हणून लक्षात ठेवा, if there is a plus I effect, if there are alkyl groups attached to the central carbon, then reactivity of that carbonyl compound decreases. As the plus I effect increases, reactivity of carbonyl compound decreases. Okay, now let us see some example. Formaldehyde, very simple example. Second is the acetaldehyde, and third one is the acetone. These are the examples of carbonyl compound. Okay, carbon having positive charge, oxygen having negative charge. In all cases, that carbonyl group is a polar. But in the case of acetaldehyde, there is one methyl group. There is one methyl group. And this methyl group shows plus I effect. There is a plus I effect. Okay. While in the case of acetone, there are two methyl group. There is a more plus I effect. Let us see comparison between formaldehyde and acetaldehyde. In formaldehyde, there is no any plus I effect. Therefore, it is more reactive. But in the case of acetaldehyde, there is one methyl group, and this methyl group shows plus I effect, electron donating inductive effect. Hence, it is less reactive. म्हणून तो formaldehyde पेक्षा less reactive आहे. Okay, it is less reactive than the formaldehyde. Okay, now what's about the acetone? Acetone मध्ये या ठिकाणी काय असेल? In the case of acetone, here there are two methyl group. Therefore, there is a more plus I effect. म्हणून त्यामध्ये more plus I effect आहे. आणि जर more plus I effect असेल तर again its reactivity decreases. त्याची reactivity पुन्हा decrease होते. And therefore, acetone is a less reactive than acetaldehyde and formaldehyde. Okay, this is just a rule of inductive effect. So that inductive effect plays an important role in the reactivity of carbonyl compound. Let us see general mechanism for the nucleophilic addition to carbonyl group. How the nucleophilic addition takes place to the carbonyl group. But let us see once again. Okay, this is our carbonyl group. In first step, what happens? Nucleophile attack on the carbonyl carbon because that central carbon having positive charge, oxygen having negative charge. Therefore, that nucleophile can be easily attacked on the central carbon. Nucleophiles are easily attack या central carbon वरती होतो. Means there is a formation of new bond between carbon and nucleophile. Nucleophile आणि कार्बनच्या मध्ये नवीन बॉन्डचं फॉर्मेशन होतं. मग इथं जर नवीन बॉन्ड फॉर्म होत असेल तर या कार्बनची व्हॅलन्सी ऑलरेडी किती आहे 4. तर इथं कार्बन आणि ऑक्सिजनच्या मधला जो बॉन्ड आहे that pi bond undergo breaking and this electron pair goes on the oxygen and that oxygen acquires negative charge. म्हणजे न्यूक्लिओफाइल आणि कार्बनच्या मध्ये नवीन बॉन्ड तयार होतोय. सायमल्टेनियसली that pi bond undergo breaking and electron pair goes on the oxygen. म्हणजे आता न्यूक्लिओफाइल आणि कार्बनच्या मध्ये नवीन बॉन्ड आणि ऑक्सिजन वरती चार्ज आहे निगेटिव्ह and we get the intermediate alkoxide ion. Okay, this is intermediate alkoxide ion. Now this alkoxide ion further adds with the proton. पुढच्या स्टेप मध्ये त्याची ऍडिशन प्रोटॉन बरोबर होते आणि त्याची ऍडिशन या ऑक्सिजनला होईल अँड वी गेट द ऍडिशन प्रॉडक्ट. दिस इज द जनरल मेकॅनिझम फॉर ऑल द न्यूक्लिओफिलिक ऍडिशन्स ऑफ कार्बोनिल कंपाऊंड. कुठलाही कार्बोनिल कंपाऊंड असेल तर त्याला न्यूक्लिओफाईलचे ऍडिशन जनरली याच पद्धतीने होते. इन फर्स्ट स्टेप न्यूक्लिओफाईल अटॅक्स ऑन द कार्बोनिल कार्बन, वी गेट द अल्कोक्साइड आयन which further combine with another cation and we get the corresponding addition product. This is just a general mechanism for nucleophilic addition. Okay, just what we have studied till we have studied introduction of this topic. या टॉपिकचा आपण इंट्रोडक्शन स्टडी केलेला आहे. What is meant by aldehyde and ketone. Then also about the next part is the nomenclature. Next part is the nomenclature of aldehyde and ketone in both common as well as IUPAC system. Then next part is the structure of carbonyl group. We have studied what is the exact structure of carbonyl group, how the hybridization of carbon is sp2, how it forms 3 sigma bond, how there is a formation of pi bond between carbon and oxygen. Now what is the geometry and bond angle in the carbonyl group. Okay, we have studied structure. Then also about the reactivity of carbonyl group, and it easily undergo nucleophilic addition reaction. We have studied some factors which are responsible for the reactivity of carbonyl group. For example, steric effect. Then also about the second inductive effect, how that inductive and steric effect plays important role in the reactivity of that carbonyl compound. Okay, or त्यानंतरचा next point आपण आता just पाहिला general mechanism for the nucleophilic addition. We have studied general mechanism for the nucleophilic addition of carbonyl compound. Okay, this is just about the introductory part.